Right now, I have 4 8TB SSDs installed in my 2.5 gigabit NAS. And with this spare, that's 40 terabytes of flash storage. The NAS runs great, don't get me wrong, but 2.5 gigabits, that's leaving a lot of performance on the table. I've been holding these SSDs back for too long. And no, I'm not going to install them in a Raspberry Pi. I already did that and found it couldn't keep up. It could barely do 1 gigabit. Today, I'm going to scrap together the cheapest but fastest storage server in my home lab using used server parts. And I'm hopefully going to be able to use it to edit 4K ProRes footage anywhere on my network. Right now I store all my video projects on my Mac's internal SSD. And that's great on that computer, but it's not a NAS. Video editing on my other Mac isn't perfect using macOS's built-in file sharing. I mean, it works, but I have a bona fide home lab now, and I want to unleash these SSDs, so I'm going to build a server with all this. A Supermicro ITX server motherboard with an Intel Xeon server CPU. I got that for $270 on eBay. 128 gigs of ECC RAM I bought used for $230 from a local e-waste recycler. 5 Samsung QVO 8TB SSDs I bought new for, well, almost $4,000. And finally, this prototype Mini ITX rack mount case My Electronics sent me to test. But I'm missing one part, and that brings me to this video's sponsor, Micro Center. I normally come here to pick up Raspberry Pi stuff in the Maker section, and of course, Micro Center is the best place to buy PCs, Macs, and custom build parts. But did you know they even sell servers and server parts? I need a boot SSD for my server, and what do you know, they have Supermicro branded server SSDs, and they even have ECC RAM. And if I needed a whole pre-built rack server, I could just take this.
Hey, but you break it, you buy it.
Right now, Micro Center's offering new customers $25 off any AMD or Intel CPU in-store only. Or even for existing customers, you can submit your build to Micro Center's build showcase and get a coupon for your next visit. Limit 1 per customer, and you can find details for both offers in the description below. Now, do I really need a brand new Supermicro SSD? No, not really. I could have used any decent SSD, or heck, even a SuperDOM if I wanted to go full-on server. But the drive does have a nice warranty. Plus, it's a good hook for the sponsor. And don't tell Micro Center, but I'd still recommend them even if they didn't sponsor me. I just wish they had more locations. But now that I have all the parts, it's time for a build montage. Alright, everything fit together nicely, and I'm really digging this prototype 2U case from My Electronics. They sent me their blue version when I rack mounted the Pi cluster for my remote farm server build, but there were a few things I didn't like about it. This new black version has more ventilation and a lot of keystone jacks, which is nice because I can expose different ports like USB, HDMI, or SATA directly on the front or the back. They aren't selling it quite yet, but they do have a page for it on their website, and they said it'll be around $200, give or take. Now, I mentioned earlier, my goal is to build a cheap but fast NAS using all flash storage. Cheap is kind of the wrong term when this entire server, even with a bunch of used parts, comes in around $5,000, but that's still a heck of a lot cheaper than enterprise flash servers like LTT's Wanix servers. But the big question is, can this thing compete? Can it saturate my 10 gig network? More importantly, will it even post? I plugged in a TrueNAS install USB and powered it up, and it did boot. I had to mess with some BIOS settings, but I got TrueNAS installed, and then it wouldn't actually boot off the NVMe drive. This motherboard came out around 2015. Back then, NVMe was still pretty new. I spent hours debugging boot problems and finally decided to drop in a SATA M.2 drive from Cytron. They sent me this thing months ago and I told them I'd test it out at some point, but well, better now than never, I guess. The SATA drive booted without a problem and I had TrueNAS running, but how did I choose TrueNAS? Well, before I set this thing up, I wanted to talk to an expert to make sure I was getting exactly what I needed from the server. I told Wendell over at Level 1 Techs I wanted speed more than capacity, and I was going to use this as an edit NAS. I had already bought the hardware at this point, but he mentioned the faster you want your storage, the more you have to worry about CPU clock speeds and memory bandwidth. The little Xeon D isn't a slouch, but it's definitely an older CPU. But Wendell said it should do fine for 10 gigs. So I also asked him about what distro I should use. I'm more familiar with Linux, but I know a lot of people build storage servers with TrueNAS Core, which is based on FreeBSD. He seemed to gravitate towards TrueNAS for this build.
What TrueNAS gives you is a lot of out-of-the-box tuning that is generally very good across a wide variety of hardware for relatively high performance, low latency, kernel tunables, memory. It's sort of tuned for like that storage, interrupt heavy, probably between interrupt from IO and interrupt from storage, kind of a thing.
So TrueNAS it is. But I also wanted to know his thoughts on what kind of drive layout I should use. I could do a RAID Z2 with all 5 drives, but I didn't know if that would eat up too much CPU power or drive bandwidth.
I mean, you could try 5-drive RAID Z2 and see if that meets your criteria. It probably will. Mm-hmm. RAID Z will have more overhead, and the relatively anemic processor and memory bandwidth will be a little bit more of a challenge. A striped mirror is with 4 drives and a spare would be dramatically faster, dramatically way less overhead. So I would say that you could probably do a striped mirror and get much closer to that 10 gig saturation.
So to make things simple, I'm just going to stick with that striped mirror and keep the 5th SSD running as a hot spare. And if you like all this kind of stuff, you should definitely go subscribe to Level 1 Techs. And of course, in the middle of my call, this happened. The other one is the petabyte that I'm going to be deploying. Whoa, I almost dropped the server.
No, that's that other Linus channel, yeah.
All right, so after the professional consult, it was finally time to set up the storage. In the TrueNAS UI, I set up a storage pool called Edit. To set it up, I picked the first 2 SSDs and added them to a data VDEV. Then I repeated that layout again so it would have 2 VDEVs, both of them set up as mirrors of each other. Then ZFS will stripe them together, making basically a RAID 10 style layout. Creating it is pretty quick. The next thing I did was added a scheduled smart test, so TrueNAS would check over the health of the drives and notify me if anything looked flaky. I let it run weekly, and then I also added a snapshot task to run daily. That will create a daily backup snapshot, but let me remind you, as always, this is not a backup. It's just a convenient way to go back to a point in time if you mess something up in this storage array. TrueNAS already set up a scrub task that checks the data integrity on the array. I was happy with the default, so I moved on to setting up a share. First, I created a user account so I could access the share. Then under sharing, I added a Samba share and enabled the Samba service. So I had my pool running, basically RAID 10 but with CFS, but I ran into some problems. First, I was getting spotty write performance. It would write for about 30 seconds, then nothing for a while, then write again, then nothing. It averaged to less than 300 megabytes per second. So I set the block size to 1 megabyte since I'm mostly dealing with big video files, and I turned off sync. That's normally a really bad idea, but in my case, I'll have a separate copy and it'll be running on a UPS, so I can accept that risk. Turning off sync lets ZFS tell my computer a file's written to disk before it actually completes the write. It just stores it in RAM for a little bit while the drive catches up. And that helped, but something was still weird. Initially, I'd get a gigabyte per second on my network copies, but then it would limp along at a slow but steady 320 megabytes per second. So maybe a cache was filling up, or maybe the disks got slow for some reason. I'm not sure. After debugging things for a while, I actually called up Wendell again to help with ZFS, and I brought in Patrick from Serve the Home to figure out what was going on with all the server hardware. I eventually threw in an HBA in the PCI Express slot since I know its bandwidth is straight through to the Xeon CPU, and what do you know, I was writing files at a gigabyte per second all day long. But I don't want to run an HBA because it would eat up about 7 more watts continuously, and I'd need to hack together a cooling solution for it. So I pulled it back out and plugged the drives back into the motherboard, and wouldn't you know, now they're getting 700 megabytes per second. That's more than double what I was getting before, so I tried over and over to replicate my earlier setup that was only getting like 320 megabytes per second, but I couldn't. And heck, 700 megabytes per second, that's good enough for me, for now at least. Read speeds are still over a gigabyte per second, and latency, boy, latency is amazing on here. I'm able to edit 4K footage in Final Cut Pro without any problems. Well, there was one problem. I had to go into the Samba settings and enable this extension to make Final Cut happy, but once I did that, I could edit off the NAS almost like it was local. So the first video I edited on the NAS is this Starlink video. It was a little simpler without a ton of camera angles or complex effects, but it worked great, and I'll probably be tweaking things a bit in the coming weeks. The most important thing is getting nightly backup set up. That way, even if ZFS fails or multiple hard drives go bad, I'll still have all the edits I was working on. Someday I might even look into hourly remote snapshots too, but for now, I've solved my problem and I have a lot more fast, low latency storage on a real NAS, so I'm not tied down to one main editing workstation. I also spent some more time getting that NVMe to finally boot, so I swapped it back in and set aside the maker disk for now. This new NAS gives me 700 megabyte per second writes and 1.1 gigabyte per second reads. And it upgrades my SSD storage from the 4 terabytes I had on my Mac Studio to 14 terabytes, even with 3 of those drives used for redundancy. I learned a lot about ZFS tuning and about making the most of used server hardware. I also learned about how to manage IPMI and BIOS upgrades with FreeDOS, and how to put quiet Noctua fans in a server and not have the fans go haywire. I put up blog posts with guides for both of those things, and those are linked below. This server uses about 42 watts of power at idle and 70 watts under load, so it's pretty energy efficient, even though it's running slightly older hardware. Will I upgrade to something more elaborate in the future? Who knows? Right now, this thing is going to give me enough overhead without eating up so much power like the Petabyte Storinator. All that's left is adding a label and installing it in my rack. Until next time, I'm Jeff Geerling.